Hello everyone, this video is going to be all about Turing Machine, which is an important concept in automata and computability, and it's a very interesting concept as well. I won't be going into the depth of this concept, just how to solve a problem regarding Turing Machine and how to draw the state diagram of it. So let's just give a brief on what Turing Machine is. It's an infinite tape which has cells, and each cell contains a symbol, and it has a head on the top of the tape which can move left or right by one step, and it can modify the content in the cell by replacing it with another symbol. For example, if you want to modify the symbol 0 in this cell, you can replace it by X. After that, you can move left or you can move right by one step, and it's basically an infinite tape. So let's get on with one example. Right, so in this string you can you can start from the first symbol, the 0. We'll look at the state diagram later, but first we need to start solving we need to start figuring out how to solve this a particular string that's given. So what you would do is, first you will start with 0, you convert that 0 to X, and then you move to the right, and then you see a 0 you ignore, you see anything other, any symbol you ignore, but whenever you see a 1 you convert that to Y, and after that you move left, and from left you again go to whenever you see 0 you go to left, you ignore. Whenever you see 0 you go to left, you ignore. Whenever you see an X you go to the right, and then you convert that to X again, and then move to the right. Then again, whenever you see a 0 you ignore. Whenever you see a Y even, you ignore. Whenever you see a 1, that time you convert that to Y, and then move left. Again we go left, we ignore Y's and zeros, and then we see an X, then we move to the right, and then we convert that X or 0 to an X. Then we move to the right, we ignore zeros and Y's, and then when we see a 1 we convert that 1 to Y. Right, then we go to the left, left, oop, and then you bumped into X, and then you go to the right, and then you convert that 0 to X. Then we again ignore the ones and Y's, we again ignore the zeros and Y's. Since there's no zeros, we just ignore the Y's, and then when we see 1 we convert that to Y. Right, and then that it could be blank later on. This could also all be blank later on. As I've said before, it's an infinite tape. Consider this is the infinite tape, left and right is blank, and we're just considering this particular position of the Turing machine. So after that, whenever we see any from this position, we can we can go to the right, and when we see any from this position, if we see Y's we ignore, and since we're seeing blank we go to the left, and when we see a blank space we go to the left by one space, and then we can stop this we can accept this symbol. So since there are no remaining symbols like X, like 1 or 0 left, since all of them have been converted to X and Y's, this Turing machine is accepted. Now how do we draw the state diagram of it? After we've completed the tracing, it will be easy to draw the state diagram. So as you can see, how did we start? We started by, whenever we see a 0 we convert it to X. What this symbol means is, what this thing means is that whenever you see a 0, you convert that 0 to X, and then you move to the right by one step. It's always by one step, it's never by many steps, infinite steps. It's not ambiguous, it's really like exact. You just move by one step to the right. So whenever you see an X, whenever you see a 0 you convert to X, and then after that, let's just look at this. Whenever at first how did we start? Whenever we see 0 we convert that to X, and then when we go to the right we ignore the zeros. So we ignore the zeros, we ignore the Y's, which will come later on. We ignore the Y's, and then when we see 1 we convert that to Y, and then we move to left. We immediately move to left, we don't look at there. We just need to match all these strings. We just need to match the numbers of zeros and ones. It's basically how to prove 0 to the power n, 1 to the power n. So we match the numbers of zeros and ones by using this Turing machine. Right, so we move to the left, After we have converted 1 to y, we move to the left, and then we ignore the zeros, we ignore the y's which might come, and then we keep on moving to the left until we reach the x. And when we reach the x, we do nothing, we do no change. See, x is converted to x, that means there is no change. And after that we move one step to the right, and again we start this process again by converting the 0 to x. And then again we ignore the zeros, then we ignore the y's here, and then when we see encounter 1, we convert that to y, right? And then after that we move to the left, and then we ignore the we ignore the y's, we ignore the zeros, and then when we see an x, we move to the right, and then after that again we convert that 0 to x. So this is how you keep on going on. And then how to end it: we know this is a infinite loop. I mean, this is a loop as long as there are strings in the as long as there is an input present in the string. And then how do we stop it? When we see that we're in the last y, we move to the right, and then if there are no other y's, we just directly go to this step. So that means we go to this is blank. This means blank space. So whenever we see blank space, we do nothing. That means we convert blank space to blank space, which means basically nothing, no change, and then we move to the left, and then we can say that this Turing machine is accepted. Right. Let's look at a more complicated example. This. So here it says that w hash w, where w equals 0 1 whole star, which that means w contains the alphabet 0 and 1. So we have to match the string. So the string is, suppose the example string is, the w can contain zeros and or ones. So it's not like it will be zeros on the left and ones on the right. That would be too easy. Here it's like just zeros and ones all together. It could be 1 1 0 hash 1 1 0. It just has to mean that this should be a mirror image of this. So hash is the one that divides these mirror images, right? So how do we solve this? Let's just try to solve this. Input symbol. So whenever you see a 0, we convert that to x, and then we move to the right, we ignore the ones, we ignore the zeros, and when we reach this hash, then we go to the right. We go to the right, and then when we see a 0, we convert that to x. And then again we move to the left, and then when we see a hash, we ignore it. We see a 0, we ignore it. We see a 1, we ignore it. Then when we see an x, we move to the right, we convert this 1 to x. We convert this 1 to y. We can divide zeros and ones by converting zeros to x's and ones to y's. Right, so we convert this to y, and then we move to the right, we ignore, and then when we see a hash, we we go to the next one, and then again we ignore x's and y's, and if we see a 1 or a 0, we convert that to whatever we converted to before. So it could be in the same loop. This could be in one loop, and this x's conversion could be in one loop, and y conversion could be in another loop, right? So again, we go to the left, we ignore the x's, we ignore the zeros, we ignore the hashes, everything, and then when we see a y, we go to the right by one step, and then we convert 1 to y again. Right. After that, we again we go to the right, we keep on going to the right, we ignore the x's, y's, and everything, and then when we see another 1 after the hash, see, after the hash, if we encounter a 1, then we convert it to y, right? Then we go to the left, we ignore the y's and x's and hashes, hashtags and everything, and then when we encounter y before the hashtag, we go to the right and then convert 0 to x, and then we go to the right, we encounter hashtag, go to the right, ignore, and then after the hashtag, after the first 0 or 1 symbol that we encounter, we convert it, and then we convert this to x. Then we move to again, this is blank before and blank after. This is like in the middle of the tape. So after that, when we go to the left, we ignore y's, x's, and everything, and after that, when we see even before the hashtag, we see no other symbol, we just see x's or y's. Then we go to the right, we keep on going to the right, ignore the x's, ignore the y's, ignore the hashtags, and when we encounter a blank, then we convert blank into blank, that means no change, and then go to the left, and then we end the process. So let's draw the uh, state diagram for this. So like I said, there will be two loops, for one for converting x's and one for converting y's, and that's why I have two loops, one for converting x's and one for converting y's. So whenever you encounter 0, we convert the 0 to x, then we move to the right, then we keep on ignoring zeros, we keep on ignoring ones, we won't be encountering x's and y's before this, so after this it's so we just keep on ignoring zeros and ones, and then when we encounter hash, then we then if we encounter x's or y's, we ignore it, that means we no change. But if we encounter a 0, we go to the next step and we convert 0 to x, and then we move to the left, and then again we ignore zeros, we ignore ones, we ignore y's. Ignoring means no change. Basically, we're not converting the string to something else, we're just converting the same thing, so no change. And then when we encounter a hashtag, again we keep on going to the left, and then when we encounter an x, then we move to the right, and then we convert whatever symbol we get. So if we get, since we got a 1 here, we're going to the second loop, we're going to this loop. It's either this or that, so we're going to this loop. So we convert 1 to y, and then we ignore the zeros and ones, then we ignore the hashtag even, and after that, if we encounter a y, if we encounter a 1, which we don't, after the converting this to 1, we go to the right, we still encounter x, so we ignore the x, and then we go to the right, and then we get this 1, so we convert the 1 to y, and then we move to the left, so we keep ignoring x's, we keep ignoring y's, we keep ignoring ones, because we'll just be we'll also keep ignoring what you call zeros, forgot to write that. So we'll also keep on ignoring zeros, even here we'll also keep on ignoring ones, zeros, yeah, we keep on ignoring x's, because like I said, this string is sort of different. It's not like you have just zeros on the left and just ones on the right. You have zeros and ones, combination of it, both on the left and right. You just need to match the number of same number and same type on both sides. So it's not just the number, you also have to match the type. In previous example, it was just the number to be matched, right? So then we keep on moving left, and then when we encounter the hashtag, we go to the left, we still keep on going to the left, and then we ignore when we encounter a y, we convert that y to, we don't convert it, we just go to the right. When we see a y after it, sorry, there was a mistake in the previous one, so I had to correct that. So when we're on the left, when we're on this stage, so suppose we're on this stage, okay, so when we move to the left, we're just gonna keep on encountering x's before this, after this hashtag we're just gonna encounter x's or y's, not zeros or ones. So at this side, we'll just have a loop for ignoring x's or y's, and then we move to the hashtag, we change it to nothing, and then we change it to hashtag, and then as in no change, and then we go to the left, and then here we're going to be encountering zeros and ones, because these places will be left unconverted, untouched. So ones will be converted to ones, zeros will be converted, so these won't be, here we won't encounter x's or y's. As in, what I'm trying to say is 0 1 1 0 hash 0 1 1 0. So suppose this has been converted x y, and then this has been converted x y. So after, from this stage, if you're moving from here, from y to left, so we're just going to be encountering x's or y's. So we encountered x, so we encounter x, we move to the left, then we encounter hash, we move to the left, then we encounter 0, we move to the left, we encounter 1, we move to the left, and then we encounter y, then we move to the right, and then again this loop is continued, this whole loop is continued, because the next input is 1, not 0. If the next input was 0, we'll just go to this loop. So after it's all been converted, after, how do we stop it? So in the end, when we're encountering in the end, when we encounter this part, look at this part, this is for this part is for this arrow. So when we encounter x, if this is finished, we are going to be at this stage of the symbol of the input. So when we are at this stage, when we encounter x, we go to the right. When we encounter y, we go to the right. And then when we encounter what you call, sorry, after this is finished, we're going to be at this stage. So when we encounter x, suppose from this stage, from from this stage over here, let me just draw it again, 0 1 1 0 hash 0 1 1 0. So after we have converted, and when we're at this stage, after everything is converted to x y y x x y y x, so after we are at the end stage, we go to the right. If we get we go to the, if we get x, we go to the right. So we encounter x here, so we convert x to nothing, and then we go to the right. And then after that, if we encounter a blank, this would be ignored because we won't be getting this input, but just in case we do, I just gave this loop here. So if we encounter a blank after this, which we do, if after x we do encounter a blank, after we encounter a blank, we change it to nothing, and then we go to the left. And then after that, as we proceed to the left, see, as you've seen, the blank is converted to blank, there is no change, and then we move one step to the left. And then after that, we reach the accepting state. That means this string is accepted. Right, so this was all about Turing machine. I hope the doubt was cleared. I know it's a bit confusing, but I personally thought that from automata and computer vision, this was the most interesting concept. This was the most interesting part. You just have to do the tracing of the symbol, match it somehow. I mean, it's not that easy. I figured this out, and that's why it was easy for these examples. But if you've seen some other types of string and you don't know how to match it, if there was no divider in between, like a hashtag or something, then it would be a different, it would be more difficult, like a palindrome sort of string. It would be more difficult to convert. So have fun with it, play around with it, then you would see that this is actually a really interesting concept. After you've figured out how to the way to solve it, then move on to drawing the state diagram. So yeah, give a thumbs up if you've understand the concept, and good luck.